Welcome back. Problem 1-46. So in this problem, it is given that the 20 kg cylinder is suspended from the wall and ceiling using rod A, B and B, C, which has a diameter of 3 millimeter and 4 millimeter respectively. Determine the angle theta so that the average normal stress in both rods are same. So from this figure you can see this is the cylinder that has a mass of 20 kg that is acting downward. This is cable BC and this is rod AB, and the rod AB has diameter of 3 millimeter and while BC has a diameter of 4 millimeter. So you have to find this theta angle for which the average normal stress in BC is equal to AB. So from given data, mass of cylinder is 20 kg, diameter of rod AB is 3 millimeter, which in meter is 0.003, while diameter of BC is 0.004 meter. So we have to find this angle theta for which average shear stress in BC is equal to average shear stress in AB. So let's start with the solution. The first step is that we have to find the internal loading. So how you will find internal loading in, so if you look at this diagram, so this is rod ABC and this is rod AB. So stress in rod AB is represented as, let this is the stress in rod AB and that is represented as FBC. Similarly, the stress in rod AB is this one and this is FBAB, and it is also making an angle of 30 degree with this horizontal, because these are vertical angles, so this is also 30 degree, and the weight of this cylinder is downward, and this weight is equal to 20 kg into 9.81, and it will be in Newton. So let apply the equation of equilibrium equation. So first equilibrium condition is sum of all forces along x direction must be equal to 0 and force taken in this direction is positive. Now you can see this FBC will have two components, one is horizontal and one is vertical. So this component will be equal to FBC into cos of theta. And similarly, this FAB will have two components, one is horizontal and other is vertical. So this horizontal component will be equal to FAB into cos of 30 degree. So we will write it, the FBC horizontal component is FBC into cos of theta, because this is in this direction, clear, so it will be positive, minus this component which is FAB into cos of 30 degree. This is, let this is your equation number 1. Now you can see we have two unknowns FBC and FAB which cannot be calculated with this. So what we will do is that we will move, we know that average normal stress that is sigma average of AB is equal to FAB over area of AB, clear, and average normal stress in BC is equal to FBC divided by area of BC. Now it is given in question that we have to find theta for which average stress in AB is equal to average stress in BC. So sigma average AB is equal to FAB divided by area of AB is equal to FBC divided by area of BC. So you can just put the value of area. So area of AB is equal to pi by 4 D square, and D of AB is 3 millimeter. So it is 0.003 square, and that's come out to be 7.069 into 10 raised to the power minus 6 square meter. Similarly, area of BC is equal to pi by 4 d square, and d is 0.004 square. So when you solve it, it will be 12.56 into 10 raised to the power minus 6 square meter. Now you can put the value of both areas over here. So FAB over 7.069 into 10 raised to the power minus 6 is equal to FBC over 12.56 into 10 raised to the power minus 6. So when you again solve this in term of FAB, so FAB will be equal to 0.5625 FBC. So this is your equation number 2. Now you put the value of FAB in this equation number 1. So when you put it, so FBC into cos of theta, I will write it, put 2 in equation 1. So FBC cos of theta minus 0.5625 FBC into cos of 30 degree will be equal to 0. Now you can see FBC is common, so take it out. FBC into cos of theta minus 0.5625 into cos of 30 degree. Now we have two terms, FBC multiplied by this term, their multiplication will give you 0. So it means FBC is equal to 0 or this term be equal to 0. But we know that FBC is not equal to 0 because this rope will have certain force. So therefore, the second term cos of theta minus 0.5625 into cos of 30 degree will be equal to 0. So from here, this cos of theta will be equal to 0.5625 cos of 30 degree, and theta will be equal to cos inverse 0.5625 into cos of 30 degree. So again, when you solve it, you will get theta will be equal to 60.8 degree. So for this angle theta is equal to 60.8. This theta 60.8. The average normal stress in BC is equal to average normal stress in AB. I hope you have enjoyed this video. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.